Hello everyone, welcome back to IB Spectrum. Today we'll be learning about how to graph sine and cosine waves. The first thing on the agenda is learning the terminology and the formulas. The first two formulas here are the sine and cosine function. The A represents the amplitude, which is the height of the wave. B is the frequency, the number of completed cycles in a given interval. C is the phase shift, and D is the vertical shift. Period. You calculate period by 2 times pi divided by the B value. The phase shift is this value of C divided by the value of B. Using these two formulas, the sine and cosine function, you can directly get the amplitude, frequency, period, phase shift, and vertical shift out of these. So there are 3 questions here with assigned points of 5, 7, and 8. You could pause the video now and answer these questions or come back to later after the video is over. Add up your points and let us know how much you got in comment section below. The second thing on the agenda is graphing sine and cosine waves. So here's the representation of how A, B, C, and D affects the waves, the amplitude, the phase shift, the vertical shift, and the frequency. This is self-explanatory, so I'll just move on to the next thing. So before actually graphing these functions, we have to understand exactly how these affect, how A, B, C, and D affects the sine and cosine waves. The amplitude, the A value, affects the range of the function. So the height of the function, the maximum and the minimum values varies as amplitude changes. The B value affects the period, and the C value affects the graph or the wave moving left or right, and the D affects the graph moving upwards or downwards. Frequency and period are inversely related. So higher the frequency or higher the B value is, the lower the period will become. What happens to a sine or cos graph when B is negative? When B is negative, the graph is reflected over the x-axis. Okay, so how does sine and cosine graphs look like? Sine graphs always start at the 0, 0 point of the graph, while cosine graphs starts at the maximum minimum value. So it doesn't matter for sine graphs what the amplitude is, it always passes through, starts at the 0.0 point, the center of the graph. While the cosine graphs, it's the amplitude that's given in the function, always starts the maximum or minimum value of the function. Now, how sine graphs look like? Here, the first one is y equals to sine x graph, and the second one is y equals to cos x graph. Sine x graph here, as I said here, it always passes or starts at the 0.0 and then moves on, while the cos x graph starts at the amplitude or the maximum minimum value. We'll be using the help of Geogebra to help understand how to graph these 5 functions. Okay, so the first function is y equals to 2 cos 3x, 2 cos 3x. Okay. So the amplitude here is 2. So the cos wave starts at positive 2 and goes all the way down to negative 2 and repeats this pattern. And here the B value is 3. And if you were to compare this graph to, say, y equals to 2 cos 1x or x, you could see how compressed the red wave is. So the red wave is the 2 cos 3x, and the blue wave is 2 cos x. So by comparing these two, you could tell that the higher the B value is, the lower the period becomes. So the wave will be compressed. So that's y equals to 2 cos 3x. Now the second function is y equals to negative half cos x. Negative half cos x. Okay. Here the amplitude is a negative number, so it start off in the negative y-axis section. So if you were to zoom in here, it starts at negative 0.5, negative half, the same thing. And it continued this. So if you were to go here, one cycle, the wave would come back to negative 0.5. So this whole area is one period, one cycle. So this is negative half cos x. The third function is y equals to 4 sine 2x. Y equals to 4 sine 2x. So here the amplitude is at 4, so the y-intercept would be at 0, 4. No, I mean around at 4, not y-intercept. It would start out at 4. The sine wave would go past through 0.0 point and go all the way up to positive 4 and to negative 4, down to negative 4, and repeat this pattern, becoming a wave. So that's the amplitude. Here the b value is 2, and if you were to compare this, if you were to find the period, so the period is, to find the period is 2 pi divided by b, and here b is 2, so 2 pi divided by 2 would be just pi, and pi would be, so one cycle would have to end at pi. So here one cycle is over here. This is the end of one cycle at this point. So here would technically be where pi is on a graph. And if you were to compare this to a similar function like 4 sine 1x, you could again tell, again just proves that the higher the b value is, the compressed it would be. So here the blue value is 4 sine x, and the red wave is 4 sine 2x. And okay, so next function is y equals to cos 4x. Cos 4x. Here the amplitude is 1. Here the amplitude is 1, so the cos wave would start out at positive 1 and down to negative 1. And the b value is 4. So if you were to find the period here, so 2 pi divided by b, here is 4. So 2 pi by 4 would be pi by 2. So one cycle would end at pi by 2, and here one cycle would be over here at this point. So if you were to zoom in, this point here would be where pi by 2 is, which is 90 degrees if you were to convert it to radians to degrees. And if you were to compare this graph to y equals cos x, there's a major difference. Look how compressed the blue wave is compared to the red wave. And now it's the last function, 2 sine 4x. 2 sine 4x. All right, so the amplitude is at 2. So obviously the sine wave would go up to 2 and then down to negative 2. And the b value is 4. So again, if we were to find the period, 2 pi by 2 pi by 4, the period would be pi by 4. That'd be the end of one cycle. That would be here. At this point here would be pi by 4. That's one cycle, one period. Okay. And that comes to the end of our video. Thank you so much for listening to us. And if you have learned anything from this video, please make sure to leave a comment, like, and please remember to subscribe if you want to continue to listen to more of our videos. Thank you.